my computer can handle doing all of this at one time. Okay. View. So, in an addition and subtraction problem, my first order of business is going to be to factor the denominators, because that's a necessary piece of finding the least common denominator. So x squared minus 9, I see x minus 3, and here. This is all apparently becoming too much for my computer to handle. Now, if I look at the number of times that x minus 3 occurs in any one fraction, that number is at most once, right? If I look at the x plus 3, the number of times that occurs in any one fraction is at most twice. So I need two x plus 3s. Everybody's okay with that? So if I look at the first fraction, I have an x minus 3. And I have an x plus 3. But I'm missing my second x plus 3. And my computer apparently is just really can't keep up here. So it needs a second x plus 3. So for this fraction, I'm going to be multiplying the top and bottom by x plus 3. Okay. For the second fraction, I have both of these, but I don't have the x minus 3, right? See that, Landon? Okay. So I'll multiply the top and bottom of that fraction by x minus 3. So far, so good? Okay. Now, can I reduce at this step? No. Why not? Because I have addition or subtraction going outside of parentheses, right? See the subtraction symbol outside of the parentheses there? No bueno on reducing. So what should I do? I should FOIL pieces, correct. So if I FOIL, I get x squared minus 5x plus 6. I'm going to ever do that. Okay. Now there's a problem with what in that it's not completely correct. I made no error with my foiling, but there is still an error here on what I've written down. Does anybody see the error, Landon? Yeah, so the subtraction here applies to this whole thing. So I need to make sure that I'm distributing that negative through to the entire fraction. My suspicion would be the majority of us would have forgotten. Okay to there? And now I can combine like terms. So an x squared and a negative x squared just kind of cancel out. A negative 6 and a positive 6 just kind of cancel out. And then 5x and 5x is 10x. And obviously 10x, there's no more factoring I can do onto that, and there's no reducing to be done, so that's my best answer. Pete?
So I know how you get the denominator, that's the least common denominator, but can you like go over it? I don't really get how you get the top.
Sure. So if I look here at least common denominator with the denominator for the first fraction, I have the x minus 3. Both of them have that. The first fraction has 1x plus 3, but it doesn't have the second x plus 3. So I'm going to multiply the top and bottom of that fraction by x. Okay. If I look at the next fraction, I have the 2x plus 3's, but what I don't have is the x minus 3. So I'll multiply the top and bottom of that fraction by x minus 3. Write this now as one fraction. I have minus, good gravy, minus 2 times x minus 3. And it's all over my least common denominator. Does that feel okay?
Yeah.
Yeah, so if I look at each fraction separately, 3 occurs in each fraction. Once in the first fraction, but twice in the second fraction. That's why I need 2 of them, because it's always the most number of times it occurs in any one fraction. Is that what you needed? Cool. Okay. That's good. This, I think in general, this skill is the one that we, as a class, seemed the furthest away on, was adding and subtracting. So I'm glad that we was the first out of the gate. This is what we want to talk about. Except you don't have to worry about the distribute piece. Yeah. Right. Eva? Sure. No problem. We can do it. So we'll start by factoring. So x squared plus 6x plus 8 multiply 8 adds to give me 6. Plus 9x plus 20 multiplies to give me 20, adds to give me 9 is 4 and 5. So far, so good. I see 3 distinct prime factors. I see x plus 2's, x plus 4's, and x plus 5's. You agree with that? And since then, in any one fraction, the x plus 2 occurs at most one time, the x plus 4 occurs at most once, and the x plus 5 occurs at most once. That's my least common denominator. It's just everything to the first. Are you okay there? Okay. So if I compare my first fraction's denominator, I have the x plus 4, I have the x plus 2, on that previous step, right? I just kind of rewrote it all in one fraction. So let's FOIL these out because we can't reduce at this step because of that pesky plus sign there in between. So when I FOIL things out, I get x squared plus 4x minus 5, and then x squared plus 5x plus 6. Okay there? And then I can just combine like terms because I just still have that plus sign in the middle of them. So x squared is 2x squared. 4x and 5x is 9x. And then negative 5 and positive 6 is 1. Is that okay to there? Oh, yeah, you just goofed on the sign somewhere or something. And then technically you'd want to check to see if you can factor that, but you should be able to look at that pretty quickly and tell that you can't. Remember, again, the easy check to see if something is not factorable is if you get that the square root of b squared minus 4ac is not an integer. You know right away the thing isn't going to be factorable. So since the numerator can't factor at all, there's no chance it can reduce, so we're done. Is that okay, Aves? Yeah, no problem. Next up, PD from the review. Sure. So the idea here with these multiplication division problems is basically all we need to do is factor and reduce, right? Well, really, we have to also write, in this case, since it's a division problem, we need to write it as a multiplication problem. And then factor and reduce. I'm going to do that all in one step. Is that okay, Pete? Okay. So to turn a division problem into a multiplication problem, what we need to do is we flip the fraction on the right-hand side, and then we can turn it into a multiplication problem. I'm going to do the factoring at the sum of the factoring at the same time as the flipping. So if I look at the first fraction, the numerator has the greatest common factor of 5x. So I'm going to take that out. The denominator has the greatest common factor of 2x. So I'll take that out. Now the denominator in the right fraction, since I'm turning this into a multiplication problem, is going to become the numerator. So there I see a greatest common factor of 4. And the numerator of that fraction on the right becomes the denominator. And I see there I can take out a greatest common factor of 5x squared. So far, so good. All right. So notice here that the factoring still might not be complete because all I did was take out greatest common factors. There still might be some more to do. So the x minus 4, there's nothing more to do with that. But x squared minus 2x minus 8, that we can factor some more. The two things that multiply to give me negative 8 and add to give me negative 2 are negative 4 and positive 2. Good there? Okay. X cubed minus 8, hopefully you recognize as a sum, of two cubes. A sum of two cubes factoring pattern. And in this case, my A is x and my B is 2. So that becomes 4 times x plus 2 times x squared minus 2x plus 4. And then if I go to the denominator, x squared minus 2x plus 4, are there two numbers that multiply to give me 4 and add to give me negative 2? No, there's not. So that one's as done as it can be. So now I'm going to start trying to reduce. So I have the x minus 4s can cancel. I have these x plus 2s that can cancel. I have the x squared minus 2x plus 4 that can cancel. Let's see, I can cancel these 5s. I can cancel the 2 to the 4, make that down to a 2. And then I can cancel some x's, so I can cancel that x with that x. And that leaves me with 2 over x squared. And I think that's it. Is that okay?
Yeah.
So again, the tricky part was noticing the sum of cubes going on there. If you missed that, you would have missed a bit of reducing there that could have happened. Groots? So this is the factoring pattern, right? This was a chapter 5 concept. So what I have here, the x cubed plus 8, is my a cubed plus b cubed. So if a is x, x cubed is x cubed. And if b is 2, 2 cubed is 8. So then I just filled in the other side with my a and b. So everywhere there's an a, I put an x, and everywhere there's a b, I put a 2. Does that sound familiar? Okay. Yeah, no problem. Again, if there's something I'm doing and you're not quite sure about and you need some reminder, it's okay. We can go back and talk about it a little bit more. That's what the point of today is. Landon?
Can you read 15 for me?
Sure. Where did that go? There it goes. And I think this one I made a mistake on my key. I think I forgot a 2 or something when I did some multiplication. Enzo was showing that to me before class and asking about it. So I think I did make a little bit of a boo-boo here. So we'll kind of clarify that when we get to it. So this is a solving problem. Clearly not a proportion since I have addition or subtraction going on either side of the equal sign, right? So I'm going to be clearing fractions, so I'll just begin by factoring. So the first denominator, I notice there's a greatest common factor of x. On the second fraction, 1 minus x. I already have an x minus 1 in the first fraction. So those are pretty close together, right? What's the difference between x minus 1 and 1 minus x? Just the signs are flipped, right? So what I'll do then is I'm just going to factor out a negative 1 and really treat that as negative 1 times x minus 1. Again, this is massively easier if you catch that. If you didn't, this gets pretty messy pretty quickly. X squared minus 1 is a difference of 2 squares, x plus 1, x minus 1. And then we have 2 times x plus 1 as my last denominator. Is everybody okay to hear? So if I look at my unique prime factors, I have a negative 1, I have a 2, I have a regular x, I have an x plus 1, and an x minus 1. And in no fraction do any of these appear more than once, right? If I look at this fraction, I have x once and x minus 1 once. This fraction, I have negative 1 once, x minus 1 once. In this fraction, I have x plus 1 once, x minus 1 once. And in this fraction, I have 2 once and x plus 1 once. So they're all used at most one time. Everybody good with that? So that is my least common denominator. So I'm going to go ahead and multiply both sides by that least common denominator and then rewrite what I have here. So I have my least common denominator times my first fraction plus my least common denominator times my second fraction and my least common denominator times my third fraction. Who's sick of this problem already? So much writing. And then my least common denominator times my third fraction. Okay. Now let's go ahead and start reducing. So I get rid of that x with that x minus 1 with that x minus 1. So I have my negative 2, I have my x plus 1, my x minus 2. And the next piece, I can get rid of that negative 1 and the x plus 1. And this is the place where I think I made my mistake. So I have 2x, and then 4 gives me 8x, and then my x minus 1. And x plus 1 and x minus 1. So negative 2x times x plus 3. And then I have 2 and the x plus 1, leaving me with negative, or minus, that's the subtraction, and then a negative 2x minus 1. So really, let's just make that a plus, since it was minus and negative. Landon.
So in the second column, you cross out the negative sign by the 2.
With the negative 1 down here.
That makes it become positive 2?
Yes. Because really you can think about it as like negative 1 times 2 is the way we wrote it initially when we wrote our LCD. I just wrote it as negative 2 because it was less symbols. But you can think about it that way. Is that okay? Yeah. Okay. So now we need to multiply all this stuff out. So I'm going to FOIL here first. And then we'll distribute through. And then we'll distribute through here. And then distribute through here. And distribute through here. Now we'll combine like terms on each side. So negative 2x squared and 8x squared is 6x squared. 2x and negative 8x is negative 6x. And then I still have that plus 4. Then 2x squared, or negative 2x squared and positive 2x squared is 0. And then negative 6x and negative 2x is negative 8x. And then this is quadratic, so let's get it all onto one side. So I'm going to add the 8x over. And here I notice there's a greatest common factor of 2. So I'm going to go ahead and pull that off. And if I divide both sides by that 2. It just kind of goes away, and I'm left with this quadratic. To solve a quadratic, I can either solve it directly, I can factor it, or I can use the quadratic formula. Looking at this, I know that I can't solve it directly because I have both x squareds and x's. If I were to try to factor it, it would have to be that long factor because the leading coefficient isn't 1. And because that is potentially rather difficult, I'm just going to use the quadratic formula on it because I think it's going to be no less work than it will be to or no more work than it would be to factor it. But if you wanted to factor it, I think this one factors from the look of it. So just using the quadratic formula. Oh, no, it won't factor, but that's fine. So -1 minus 24 is -23. Oops, it's over 6. And when we square a negative, that makes an I. And the 23 is prime, so you can't break that down anymore. So you're just done. Is that okay there, my peeps? So Enzo, this is the actual answer for that one. I don't think I made another mistake on there. Yeah,
So I have a question. It doesn't require you to actually do any work, but
okay.
like 4 questions, like 11, 12, 13, 14.
Let me go up and look at what those ones, okay.
Those ones, how do you know whether to use the quadratic formula or use the solve for x?
Well, it depends if you have a quadratic at the end, right? Do you have an x squared at the end? If you don't have an x squared, you don't need to use the quadratic formula. And if you do have an x squared at the end, you might still be able to just factor it or solve directly. You might not have to use the quadratic formula, though you could. So if you have an x squared at the end, you can use the quadratic formula. If you don't have an x squared, you can't. But is that good enough?
Yeah, thank you.
Yeah, no problem. So I think the first couple, you just end up with a linear, like just x at the end and no x squareds. So you can get away without having to use the quadratic formula. I think on those first two at least. You landed.
So for number 10, I don't understand, like, you have to use the least common denominator in the actual, like, I should get where the numbers are from on the.
Okay. So I want to look at 10. Okay. So I gave you this yucky looking thing, right? So I said this, or what might be easier for us is to think about it this way. This is the way that I would recommend that you guys think about it. So we're just going to do 2 adding and subtracting problems, and then take those answers and divide them. So the first thing I'd want to do if we're adding and subtracting is to make a common denominator. So I would need to start by factoring my denominators. So over here, I notice the least common denominator would be x minus 2 times x plus 2. And over here, my least common denominator would also be x minus 2 times x plus 2. Do you agree with that, Landon? Okay. So the first fraction has the x minus 2 and the x plus 2. So we don't have to do anything to that one. The second fraction has the x minus 2, but doesn't have the x plus 2. So that's what we have to multiply to that first, or that second fraction. So that's just that x. And then there's my You good there?
I got it now. I just didn't see, like, I didn't understand, like, the whole least common denominator.
Okay. Should we finish this one out for anybody else, or do you guys just want to forget it, move to the next one? Roots? Yeah, finish it? Okay. So then let's look at the second fraction here. So I have the first fraction, we have the x plus 2, but we don't have the x minus 2. So we'll multiply the top and bottom of that by x minus 2. The second fraction, though, we have the x minus 2 and the x plus 2, so we don't need to do anything there. Oops. And here's a place, again, where we have to be a little bit careful because of that subtraction symbol and make sure that we distribute our negative through. Is that okay, Kate? Or Elizabeth? Sorry. Okay. All right, so we'll just do all our distributing here. So I have x plus 4x plus 8 over that. And then we have 3x squared minus 6x minus x plus 1 over that. So far, so good. Combine my like terms. I have 5x plus 8. And I'm going to combine like terms and flip now, since it's division. Is that okay? Caitlin? I'm sorry. Elizabeth? Okay. And then and we're just left with 5x plus 8 over 3x squared minus 7x plus 1. So that works, and that's kind of like the naive way of doing this. You want to see the super shortcutty way to do this? No? Okay. That's fine. You don't have to. It's a little bit more higher level concept, but it takes a lot less writing. But if you understand this and you're good with this, that's fine. You don't have to, certainly we don't have to talk about another way to do this. I chose to do this way, even though it's maybe a little bit more writing, because it should be pretty clear what it is that we're doing, since it's just the order of operations using the tools that we already know how to use. The other method would have been doing something a little bit different that's not as trivial as why this would work. So I don't blame you for being like the day before a test, being like, nah, I'll just take the basic. Give me the basic. Totally cool. Who's next? Do you want to talk about some more of these? Elizabeth? 13? Let's see, I think we had that already over here somewhere, right? Yeah. So first thing we'll do is start by factoring the denominators. So the first one, I noticed there's just the greatest common factor of x. So my least common denominator is going to have the distinct factors 2, regular x, and x minus 3. And since none of those occur more than one time in any given fraction, that's my least common denominator. I guess it goes without saying that this wasn't a proportion, right? Because we had two fractions being added on one side. I guess I should mention that at least. So we'll now multiply both sides of this by the least common denominator. Plus 3 minus 3. Elizabeth, you so far so good? Okay. So I can reduce the x minus 3, reduce the 2x, reduce the x minus 3. So 2 times 2 is 4, and then x minus 3 times x plus 3, and then 2x times x plus 1. So I'm going to go ahead and FOIL this stuff out here and distribute this through. And I'm going to move everything onto one side because it's a quadratic. So when I subtract x squared from both sides, I just get x squared. I'm not subtracting any x's, so the 2x stays the same. And then 4 minus 9 is negative 5. And when I add that over, I have a positive 5 then, right? And now to solve this, it's quadratic. I can't solve it directly because I have both x squareds and x's. It's not factorable because there's not two numbers that multiply to give me 5 and add to give me 2. So I have to use the quadratic formula here. So 2 squared is 4, minus 20 is negative 16. When we square root a negative, that makes an I, and the square root of 16 is 4, so I have 4i. And then I can really think about this as like two fractions. So negative 1 plus or minus 2i. Although this step here would have been still okay for me. You're welcome. So I want to take a minute and at least talk about getting the right points out of our calculator for the graphing piece. Because when I looked at your guys' graphing stuff, they looked like a bunch of hot garbage for a lot of us. And my suspicion is that we just were not getting things into our calculator correctly. So I want to take a minute and deal with that. Ugh. It was so laggy. Oh, sorry, OneNote's cleaning up from the last time it was open. Well, I didn't really want to close it, OneNote. Sock it to you. All right. Okay. So, if we remember things in this form, look like this, where the horizontal asymptote is y equals k, the vertical asymptote is x equals h. So our horizontal asymptote is y equals 2, and our vertical asymptote is x equals negative 1. Everybody's okay there? So negative 1 is going to go in the middle. And then the value is less than negative 1. and 3 values bigger than -1. And now to get this to come out, or to get the y values, what I'm doing is I'm just plugging in the -4 in for x. Right? So we have to be careful how we're doing this. So if you tried to just do this, you're going to get the wrong answer. That is incorrect. The reason it's incorrect is the calculator is going to follow order of operations, and it's going to divide the 3 and the -4, and then add the 1, and then the minus the 2. You want to make sure the -4 is added to the 1 before you divide that result by the 3. So you have two options. You can use a parenthesis there around the entire denominator, which is fine. Okay. Or you can use the fraction command. So if you press alpha and y equals, that opens up the fractions menu. And if you choose the first one, the n over d, that's short for numerator over denominator, it'll put the fraction bar in there. So you can type it into your calculator exactly as it looks on your sheet of paper. The only catch with doing it this way is that the calculator is going to give your answer as a fraction back to you. To force it to give you this answer as a decimal instead, since we're graphing, that's going to be much more meaningful to us. If we press the math button, we can choose the decimal command and just tack that onto the end. And when we press enter, it'll output us our result as a decimal. Now this was a whole number anyway, so like that's not terribly meaningful. Well, here's the nice part about doing it this way. If you can do it all in where you can do it all in one line, Peter. So if I press second and enter, it'll input the last thing I typed in. So I can just go back and change that -4 to a -3 and press enter again. Yep. Will give you the last thing you typed in, and if you pressed it second enter a second time, it'll give you the second to last thing you typed in. And you can go back, I don't know, like 10 or 12, something like inputs back. It has a little bit of a memory for you. But this makes life pretty easy to go back and then just edit the one value that you need to change. I like doing it with the fraction command because it's easy to kind of goof up your parentheses. Much more difficult to goof this up because it looks exactly like it should on your sheet of paper. That's really nice. And then all I have to do is set it up once, and then I can just do that second and enter and just change the one input, and I'll get all the y values for me.
So you just like go back in there and like delete the -2, for example.
Yep, and then I would change it to a 0 is the next one, and just keep on going, filling in my table. So I noticed that a lot of you guys are getting kooky looking graphs. Either the result being that you goofed up finding the vertical asymptote, or I think just as likely we were inputting stuff into our calculator, not actually getting the correct y coordinate. Based on some of your guys' pictures, it seemed like the asymptotes were in about the right place, but you had like all kinds of gonzo looking points all over the place, and it's like, well, I don't know, it seems like this is probably the likely candidate, as we were just not thinking too hard about what we were telling the calculator to do, right? We got to be careful. The calculator is very literal, where you know what you're saying, but the calculator doesn't know what you're saying, because you and the calculator are speaking two different languages. All right. Does anybody else have anything else to talk about here? We have a few more minutes. Landon?
This video is going to be on.
Yes. Okay. So, what I also am going to offer for you guys is for your test, you can make like a half a sheet of paper of notes. When I say half a sheet of paper, I'm talking about like a standard size piece of paper. When I say half a sheet, you can write on front and back. When I say write, I mean handwritten. You can't print out, like you can't take the review key and like telescope it down like 150% and like cut it out and paste it in there. Like you have to write it yourself. If you can write like mega small and get everything in there that you want, you can write mega small. And then you have to turn it in with the test. So you'll staple it to your test and turn it in.
So it's just half a sheet, both sides,
I'd like it to be just half a sheet, both sides. It's easier for me to like make sure that it's on your test because it's like super obvious that it's stapled on there versus a whole sheet, which is maybe easier for me to overlook. Mostly for turn-in purposes is why I want it. And then if it's one sheet, I have to check the other side of the sheet to make sure didn't write on that. If it's just a half a sheet, I don't care if you wrote on the front and back because you can do that. So that's my justification. Makes it easier for me to check, basically. But everybody okay with that? All right. I'm tired. Who feels better about what's going on, though?